In the final stages of your journey as a citizen scientist, I hope to bring together what we have learnt together so far to prepare you for the next step in your journey, which is to engage in ground truthing to identify remnant native forest, to locate it on the ground, to map it in real time, and take your information to the authorities to ensure it is protected. But before we do that, we must conclude our desktop training. We've learned how to import shapefiles, and we've learned particularly how to focus our activities on the existing plantation boundaries within our state forests, and to understand how they sit within the so-called plantable area. And we've learned how to import maps, particularly from Plan Portal, focusing on the Harvest Plan operational maps, and also how to import and manipulate the historical aerial photography that is necessary to identify ground zero. So today I want to go into this particular area of plantation. This is in Arara East State Forest, and at the time of producing this module it was still being actively logged, but we have been able to identify the remnant native forest within it and begin the process of engaging with Forestry New South Wales and all other plantation managers across the country to identify and protect native forest inside our plantation areas. With your help, we're making a difference. And by focusing on and learning from the course training materials, you can have a direct impact yourself. So obviously, as we know, the first stage in beginning the identification process is to look at the metadata within the plantation unit to identify its age class. In this case, 1982. We've gone to the historical photography, and we found the closest and most useful map or image. We've imported that as a large-scale aerial photograph, and we've created a close-up. So the process I want to take you through now is how to identify remnant native forest within the plantation area and to map it by drawing polygons or mini shapefiles around it. One of the first things to do when determining the presence of native vegetation inside a plantation area is obviously to look at the conditions on the ground. Even though this is a black and white photograph, you can still see the impact of previous forestry operations. In this case, the 1982 establishment of plantations. On this, an aerial photograph taken just a couple of years later. Here we can see that this area has been extensively clear felled. These striations in the image, or strips, is the windrowing of the logged forest, the remnants that were there after the operations, which were then piled up and burned. Here we have a set-aside area. We know that because when we put the cursor into it, it turned into a hand, indicating it's potentially not mapped for logging. and we can see the difference in the vegetation. Our task is to identify that type of vegetation by looking at the structure of the remaining canopy and draw a polygon around it to have it clearly identified as native forest. It's important that we use the black and white photograph because this is the stage at which we can see the worst of the clearing and what is left. If we take that layer off and look at the area as it existed in this case in 2017, which for Arara East State Forest is the highest resolution image on Google Earth, we can see within this same area a difference in the canopy compared to this area in the middle. It's a lot smaller, meaning it's a lot younger. So we begin the process by having a general investigation of the area as it exists now. Yes, this looks generally like young plantation. Up here, this looks like it's had some previous selective logging after the plantation was established. But if we start going into some of the corners, we can see that there is some larger trees. Sometimes that's because the edge effect in a plantation encourages increased growth, but in this instance, it's because it's connected to the surrounding native forest outside the plantation. So we can get a rough indication by looking at the imagery as it exists now as to the condition on the ground. This, for example, is quite interesting. This looks older or larger. This area looks like it's quite even. And if we zoom out, it looks like it's been planted, but maybe slightly older than the plantation area here. And then, if we go down to the bottom area here, the difference is quite clear. This area looks very similar to the native forest, state forest outside the plantation boundary, and looks quite different from what is inside the plantation. And yet, it is in the plantation. So in this instance, in Arara East State Forest, it's worth remembering that this area is being actively logged now. So we can also go to the harvest plan operational map and superimpose that to see just how much forestry intends to remove. And these yellow, light yellow areas indicate clear fell full-scale removal of the plantation area, and if you notice, including that area down at the bottom. That's well and good, but as I've indicated, sometimes plantations grow at different rates, and it is easy to be confused by looking simply at the current state of the plantation. It's important, therefore, to go back to the historical photography, identify our so-called ground zero, and work from there. So this is a close-up of that 1984 aerial view. And as I indicated, it's well worth looking at the corners and the nooks and crannies to see what's left. Here, for example, is a potential patch of remnant native forest. And down in this bottom corner, as I showed you earlier, even in this low resolution image, you can clearly see the difference between this area and the plantation proper. This area was not logged. However, it's also important to remember that forestry engages in multiple stages of logging and clearing within our public forest estate, and there are different stages in the clearance of some areas. So it's also important to go through the historical aerial photography and identify potential clearing that has happened later. In this case, in this plantation, there was some further clearing in 1998, and in identifying our polygons, we've had to check that image with this image that you're seeing in front of you. Also, once we enter into the 2000s, particularly with Google Earth Pro, we have the image over time. This is how the plantation looked shortly before logging began. But if we go back to the earliest image available, which in this case is 2004, we have a further indication of the extent to which the remnant forest remains and the plantation is developing. And we can go further forward in time again, and this helps us identify which areas have been affected and which have not. But for this exercise, let's go through the 1984 image and begin the process of identifying the remnant native forest. Remember, we create our close-up from a larger image to make it more manageable. At this stage, I should emphasize that as citizen scientists, we are engaging in what we might want to call a quick and dirty evaluation. We are simply looking at an aerial image that has been superimposed quite roughly over Google Earth Pro. It's not perfect, but it's a start. And with thousands of plantation subunits, many of which, or most of which, contain remnant native forest, we need to start somewhere. And as citizen scientists, we need to start that process first to sort out the real areas that could be under considerable threat. And I am afraid to say there are many of those, covering many thousands of hectares. So why don't we start? Let's go back up to this area here. And this is when we begin the process of drawing polygons around what we think might be the historical existing remnant native forest at ground zero time. Here's our little polygon icon, add polygon. And for our polygons, we want them to be red at a width of 3 and to be outlined. And then we begin the process of drawing our polygons. There are two ways of drawing a polygon. One is to simply use your mouse as if it were a pen and to draw the polygon as if it were a line drawing. The second option, and sometimes it's good to use this in combination, is to use the simple line function, especially when you are close to the edge with straight lines. If you hover your cursor over your point, you can also move it and have it closer to the boundary. We don't necessarily want our polygons to be right over the boundary, because in some cases this can confuse later spatial analysis if we want to import our polygons, our shapefiles, into other GIS systems like ArcGIS or QGIS. Then, if we want to work more closely, again, making sure that your point of origin with drawing your polygon is blue. You can move the dot and reshape your polygon. Here I'm moving this down this way, making this green, and going through basically the process of refining that polygon. Okay, you've now drawn your polygon. And look, it's frustrating. You'll make mistakes, your boundaries won't be perfect, etc., etc. Here's a little bit that could be pulled out here. That looks like an original tree to me. But you have to stop somewhere, or you'll go on forever. Okay, at this point we're now going to save this polygon. First of all, go to measurements. How big is it? Well, we're metric here in Australia, and for the area we want to measure it in hectares. This is 0.37 hectares. So now, for our record, we put in this year, 1984, the ground zero year. It's a remnant, and it's 0.37 hectares. And we save it. And here it is. Not quite in the right location in our file architecture. So I'm going to select it, and I'm going to pull it up to the top where it says Aurora East. Let's go down here and do that exercise again. You know how I love to tilt and compass. And for argument's sake, in drawing this polygon, I'm going to say it roughly starts here. I'm going to stop it somewhere around here. I'm going to go through that process again. of using the lines themselves. Yes, this goes on and on as a process. If you zoom in here, you can, if you've got good eyes, you can very often see the actual corners of the original lines themselves. Here there's a slight ding in it. That's from the original person who created this polygon and did basically pretty much exactly what I'm doing. Let's move this fellow out of the way. Don't worry, you'll get used to this. It's not as hard as it looks. In fact, it will become second nature. And we don't have to be perfect. We just have to try and identify the forest that we're trying to protect. 0.75 hectares, and probably a bit more, and I could fiddle a bit more with that polygon if I wanted to, but at this stage we'll just say 1984 remnant 0.75 hectares, and again we'll save it. And we basically go through that process across the area in question. A couple of other things. This is probably a remnant tree. Forestry must protect those, and as a result of our interventions already has changed that wording from should to must. But we can't really bother ourselves, as much as we might want to save this area, with something that is at such a size of 0.0 hectares that we can't actually map it directly using Google Earth Pro. We're rough and ready types, remember, because we'll do more refined work as we go on, and you learn more in later stages as you become more and more proficient, and if you stay involved. At the moment, we just need to do the basics, because so much of this is being cleared that we have to protect as much as we can, but we have to be honest about how we do it. Here's a little patch over here, which I'll just do as a quick process. So sometimes I do this if I'm trying to work out whether it's more than 0.1 hectares, and this one is. So I'd probably cancel this at this stage and then draw a proper polygon. Also, as I indicated, there are some changes in land use within the plantation units over time. So we have to make sure that we don't let just 1 year of imagery trick us into thinking that it's all either there or it all has gone. I'll just quickly take us to Tucker's Knob, another area that our citizen scientists are working on right now and which is under threat right now, and show you an example of 2 sets of clearing within the one plantation area. So if we go to the historical imagery that we have, bear with me, as you can see we've been extremely busy in trying to protect this area. I'm going to turn on the 1984 imagery. And here we can see how this area has been established as a plantation. This says 2011. So obviously forestry has gone in at a later stage and logged it. Oh, I'm in Aurora. Silly Timmy. If you remember, I think, what did this say? 2011. Let's go back to 2011 and it's been cleared. But if we go back to 1984 and we click on this area, for example, this says 1980. This is the plantation with a little bit of regrowth in it, probably not particularly fully logged or cleared, so there's been some native regrowth. In this one, again, 1980, and you can see the lines of the plantation itself. If we click on this one, it says 1990. So this area was cleared in 2011 or 2010-11 and established as plantation, probably after it was already plantation. This area in 1980 had not been logged, and it wasn't until 1990 that this patch of native forest was converted to plantation. It's this kind of thing that we're trying to stop now. And if we turn on the historical imagery from 1994, 10 years later than this image, you can see it was converted to plantation. But you can also see here is the forest that still remained at that point in time. And so off we go again, drawing our polygons and saving what we can. Meanwhile, back in Aurora East, having noted some of those tricks, i.e. that plantations are not always static and subsequently get logged, and we have to be aware of this. Once we've gone through that process of identifying the historical ground zero, drawing our remnants, we can go through that whole process ourselves. And the end point of which is we've identified a whole swathe of remnant native forest inside those plantation areas. Areas that we could save with our interventions with the authorities, particularly with Forestry Corporation of New South Wales, but this could be the Department of Agriculture, Forestries and Fisheries in Queensland. This could be Sustainable Timbers Tasmania, so-called, in Tassie, the old Forestry Commission, etc. And here, if you look, you can just see exactly how much invisible forest, until we drew a polygon around it, existed. in this area and which would have been logged if we hadn't begun this process together as citizen scientists. So that is how we draw our polygons. That is how we identify our native forest. And it begins the journey of looking at what is in there and wondering what it looks like now. This, for example, that looks interesting. We need to ground truth that, and then we do what we call dropping a pin. Untitled place mark. We don't know what it is. Do that again. Add place mark. Take it to it. And look, here are the latitude and longitude. So when we begin our course on ground truthing, you will know how to do that and where to go. That is another chapter. But you can begin it once you've started mapping just from your desktop by doing the visual yourself. This looks like the canopy of a large tree. Well, let's have a look. Let's take off that close-up. And there we go. That is the canopy of quite a large tree. And that would have been logged if we hadn't done this exercise in Aurora East. And I'm really pleased to tell you that because of our work, this area was saved. Let's go out and save some more. Bye.